Okay, so as we said, to be on the safe side, NB should be positive to not allow for overturning of the table. So to satisfy this condition, you should have omega table times B larger than omega man times A. So omega table should be larger than the weight of the man times A over B. Okay? So if you fix the distance between your supports, if you have this distance A known and B known, you can, for a certain weight, for a certain maximum weight to hold, you can determine what is the safe weight of the table to have in order to avoid any overturn. Okay? Any question on this part?
لازم نجيب الويت تبع المان.
Can you please repeat?
لازم وما فهمت شو ما نجيب الرياكشن تبع
نحن جبنا
NB
الرياكشن،
هيك.
نحن جبناها. اوكي، نحن فينا نجيب الرياكشن هون، بس لانه هن ما عطونا الويت اوف تيبل، هن قالوا لنا ميك ا كونكلوجن. اوكي، يعني ليك شو عطيونا؟
conclusion.
ايه، هيدي الكونكلوجن، لانه ما عطيونا الويت اوف ذا تيبل، عطيونا الفاليو اوف بي وسي واي والويت اوف ذا مان، فطلعنا نحن النورمال رياكشن فانكشن اوف ذا ويت اوف ذا تيبل. اوكي، بس نحن شو الكونديشن؟ يعني نحن تيضل في اكويليبريوم لازم ما يكون في overturning، يعني ما لازم نخسر الكونتاكت مع البي. اوكي، اذا ما بيكون
Yes.
عالي التيبل، الويت اوف تيبل انف، ساعتها اذا كثير كبير الويت هون بيقدر يعمل overturning effect and you will lose contact with B. So what the conclusion you can do to maintain equilibrium and to avoid overturning, and B should remain positive. اوكي، وتضل ان بي positive، لازم WT times B يكون اكبر من WM times A. And if you use this condition and you replace your numbers، بيبين معك انه تكون ان بي positive لازم يكون W of the table larger than 67.5 LB. اذا كان اصغر ساعتها ان بي بتصير negative which is impossible، لانه انت بس يكون عندك reaction بين two surfaces ما فيها تكون النورمال نيجاتيف. هي شو فيها تشد؟ انت اذا عم بتشد لتحت الجراوند بيشد عليك لفوق، بس انت اذا بتحط فورس لفوق بتشيل الاوبجكت، ما بتقدر تعمل اوبوزيشن. يعني النورمال ما فيها تكون نيجاتيف، منا فورس او منا الكتروستاتيك فورس او ماجنتيك فورس تقدر تعمل سكشن افكت او شي فورس داونورد، مجبوره تكون towards the
يا
object.
بوزيتيف يا بلاها.
exactly. فاذا ما طلعت بوزيتيف، اذا طلع لك جواب نيجاتيف، يعني اصلا ما بقى في كونتاكت، اصلا هي ما فيها تكون نيجاتيف، فيها تكون بس مينيمم زيرو.
فيها تكون
بس توصل لزيرو يعني you lost contact between the two surfaces. اوكي؟
ايه نعم فهمت المنطق.
اوكي. Okay. Another problem. Let us consider the following problem. هلا بس لا، هيدا اذا بدكم هيدا في شوي كوساين. ايه خليني اذكركم، هيدا بيذكركم بالكوساين والساين لوز. So you have a toggle switch consisting of a cocking lever that is pinned to a fixed frame at A and held in place by the spring, which has a non-stretched length delta. Determine the magnitude of the resultant force at A and the normal force on the peg at B when the lever is at the position shown. So if you look at your figure here, you have several forces. Our object of interest is the lever here. We want to study what are the forces acting on the lever, and the lever is in equilibrium conditions. Okay, to ensure equilibrium of your lever, you should have you can write on it sum of forces equals 0 and sum of moment equals 0. Now let us start by drawing the free body diagram of my lever. So what are the forces acting on it? First, it's attached to a spring, so you have a spring force acting on it. Plus this symbol here, you have here a circle, and just this circle is in contact with the straight line of the lever, so it's a roller. And you know that that a roller can just develop a normal reaction. So you have NB here. So this is the force of the spring. I can call it T, and this is normal at B. Okay. Now for point A, you have a pin. Why it's a pin؟ إن هيدا كأنه مسمار هون. Okay. Because إذا تخيلتوا إنه هون في مسمار I cannot move. ليش منه رولر؟ أنتم معودين الرولر إنه سيركل يعني رولر، بس انتبهوا رولر بده يكون هيك، بده يكون an external contact مع البودي. هون رسمنا الليفر and we have it inside، يعني كأنه مثل مسمار حطيناه وتنثبت الليفر بهيدي البارت بالفريم. اوكي. So إذا تخيلتوا هون في مسمار only I can rotate around it. I cannot move ولا in X ولا in Y. For this reason when you draw the free body diagram بده يكون عندكم two reactions. هلا فينا نحط two reactions like this horizontal و vertical. بس in this problem you can select another frame for simpler calculations. يعني مش أنا عندي lever line هي this one already I have that B is perpendicular to it. يعني ديجا بعرف إنه الرياكشن at B is perpendicular to this line. فأحيانا لي آخذ frame مثل ما كنا نعمل بالincline. Whenever you have an inclination كنا ناخذ X و Y وحدة along the inclined. So X along the incline. So this is AX. And Y perpendicular to the incline. So this is AY. This will facilitate for us the calculation. Okay, هلا you can select the frame that you want. كلهم صح. وآخر شيء بس جيبوا the magnitude of the reaction حتطلع the same. But for simplification of formulas, always try to select the frame that will simplify your equations. And finally, فإذا قلنا AX, AY, NB, and the spring force. Okay, so these are
طب شو
our
السؤال؟
سؤال جيب الرياكشنز. Okay, if we go back to the given, find the magnitude of the resultant force at A. يعني بدنا نجيب AX و AY ونعمل radical AX square plus AY square. And also we want to find the normal reaction at B. So we want to find the external reactions. Okay. Now, in order to solve for these three unknowns, مفروض نكتب equation of equilibrium. Okay. So again, let us look again at this on the figure. You have that you have AX, AY, and B and the spring force. هلا already for AX و AY و NB it's fine. I know the directions. NB perpendicular to X, يعني along Y. AX is along X, AY along Y, fine. But then the one problem, which is, what about my tension? My tension is doing an angle with the incline. And I should find this angle to be able to do sum of X equals 0. أنا بس أكتب sum of X بدي أعمل projection للtension. Okay? So I should find what is the value of T along X. To get Tx and Ty, so this is my Tx. This is the projection of T along X. This is the projection of T along Y. To get these forces, I need to know what is the value of this angle here, this small angle. Okay? هلا إذا بتتذكروا علمكم وقت أخذتوا مع الجيرمان instructor علمكم how to get angles in triangles. Sine ما تنسون sine law و cosine law. If you look at this triangle here, sorry one second. Okay. If you look at this triangle, look, you know this distance at the, it's A plus B. A and B are given. A plus B is 400. So you know that this is 400 millimeter or 0.4 meters. Okay. You know also this distance also given. This distance C is given. It's equal to 300 millimeter or 0.3 meters. Plus they gave you this angle here. This angle here is 30 degrees. And because this is a vertical line, okay, if this is 30 and the whole angle is 180, then the angle in your triangle here is 150 degrees. And remember well, when I introduced for you in class the sine law and the cosine law, I told you that if you have two sides and the angle between them, what can you find? You can find the length of the opposite side, this one. You can find this length from this point to this one, okay? This is by using the cosine law. If I call this distance L, I can say that from cosine law, L square is equal to 0.4 square plus 0.3 square minus 2 times 0.4 times 0.3 times cosine of 150, okay? Cosine 150 degrees. This will allow you to calculate the value of this length L. Now, once I find this length, how can I use it to find the angle here? Now I can use sine law. So if you remember from sine law, what can I write? I can write that the length of the blue side, which is L, over sine of the opposing angle here, which is 150. I want to find which angle now? I want to find this angle here, okay? I will call it phi. Phi is opposing which side? It's opposing the side of length 0.3. So I can write that this is equal to 0.3 over sine phi. Okay? And since I calculated L now, I know the value of L, I can find what is my phi angle. Okay? And now, once I have phi, I can project my tension force on X and on Y. But also, my tension is unknown. How to get my tension? Always remember, whenever you have a spring, this is a spring. We got together what is the total length of the spring. And they gave us the stiffness of the spring. We know K. We know now the total length. So we can deduce that what is the tension? It's not unknown anymore because the tension is K times delta L. And delta L is equal to the total length, which we calculated now, minus the unstretched length, which is given, delta. Please pay attention for units. When they give you K in Newton per meter, you should also have delta L in meter. So here convert to meter, yani 0.2. You get L in meter as we did together, and you subtract minus 0.2. You calculate your tension in Newton. Once I have T and phi, I am done because the remaining part is very simple. I still have to calculate what should be AX, what should be AY, and what should be the normal reaction. I need to write 3 equations, okay? The first equation is sum of forces along X equals to 0. Let us decompose along X. We consider AX, as we said, positive upward along the lever. So we have first, yeah?
جبنا الدلتا ال تبع السبرينج.
Okay. كيف بنجيب دلتا ال of a spring؟ شو الفورمولا؟ Total length of the spring. Okay. شو هي total length of the spring؟ هلا جبناها انا وياكم بالكوساين لو، مظبوط؟ اوكي. فالدلتا ال هي total length. شو الديفينيشن of دلتا ال؟ total length minus L0 صح؟ L0. بس هون هن L0 مسميينها دلتا. هن عطيوني اياها لانه اذا بترجع على الجيفن قالوا لنا the unstretched length of the spring is delta. Okay.
هي خلص.
Okay. Fine. So now I write my equation. The first equation is sum of x equals 0. What do I have along x? I have plus ax concerning my AY و NB اثنيناتهم along Y يعني ما بحسبهم projection 0 على X. I still have the X component of the tension. As you can see here, the angle between the tension and the X direction is phi. So I do minus T cosine phi equals 0. And I already calculated T of phi. So I did use that the value of AX is equal to T cosine of phi. Now, I am done with AX. Let me calculate AY. To find AY, I do sum of Y equals 0. So I have plus AY plus NB. And I have a negative projection for T along Y. It's T sine phi. So minus T sine phi equals to 0. But this is not enough. Okay, these two equations are not enough because the first equation gave me AX, but the second equation involves two unknowns, AY and NB. So to find one of these two, or to find another equation relating these two, I need to get a moment equation. The moment equation, you have several choices. If you do sum of moments about A, it is good because you cancel AY. You can find what should be NB. And if you do sum of moments about B, then NB will cancel out and you find AY. And in both cases, if you find AY or NB, you can replace back into equation 2 and get the other unknown. Okay, so you can do whatever you want. Even you can select any other point. And if you do sum of moments about this point, ساعتها AY حتكون فيها موجودة بالإكويشن وكمان NB حتكون موجودة بالإكويشن. بيطلع لكم a second equation relating AY and NB. So you solve two equations with two unknowns. It's up to you. Select whatever you want. Let us say we considered sum of moments about A. When we do sum of moments about A, no moment for AX and no moment for AY because they pass by this point. So I can write that sum of moments about A is equal to 0. I will consider the counterclockwise as positive. So I have first, for NB, it's producing a counterclockwise moment. And the distance from NB to A is small a. So I have plus NB times small a. Now for my tension, I can decompose it into two components, Y and X. The X component will not do a moment about A because it's passing through A. So I only have to take into account the moment of the Y component. I know that the magnitude of this component is T sine phi. And now I just have to look at the distance. The distance from A to the tension is equal to A, so plus B, okay? So now this is the whole distance I should take. It's A plus B. And then all I have to do is to look at the direction. It's in the clockwise direction, so it's negative. So I can write plus NB times A minus T sine phi times A plus B equals to 0. In this equation, the only unknown is NB. So I find NB. So NB will be equal to T sine phi A plus B over A. And then once I get NB, I replace back into the previous equation, I get A1. Okay? Any question on this problem? Okay, so let us start another one.